To the video for the Lesson 5 um, lesson in Yo 50 class. Lesson 5 is about problem solving. Um, want to use some of the things that we've done before. Hopefully, you went through the prep skills. The main thing is going to be writing expressions. Um, I'm sorry, actually, the main thing is going to be using dimensional analysis, but writing expressions will also be important. So make sure you do the prep skills and read through the um, introductory paragraph here. Um, and once you've done that, come back to the video. Okay, now that you've done the prep skills, the classwork kind of starts with an introduction of um, the steps in problem solving. Problem solving is where you're given a question and you have to find an answer using math. Um, it's different than what most people are experienced with in math because you have to write your own formula or find your own equation. You're not given an equation to solve. You're not given a formula to plug numbers in. You have to find your own formula. Um, that's that's something that most people are not really used to because it's not done in math class a lot, but it should be because that's the only way you'll ever use math. This is how you. Um, this lesson is helping you use math um, in real world problems. So it's important, probably the most important lesson in the class. Um, so, steps in problem solving. So first of all, understand the problem, um, and understand the problem really in several sub steps. First of all, read the problem. Uh, Identify what the problem is asking you to solve. That's part of understanding the problem. Identify the question that it's really asking. What is the quantity you have to calculate? Um, and then, in addition to that, you want to identify the information that you're given. You're not going to be given the answer, but you'll be given things that you can use to calculate the answer. Um, Sometimes there'll be intermediate steps where you know that you need a certain number to find the answer, but you're not given that number. You're given other information that allows you to calculate that number. And that's really what step 2 is, where you devise a plan to solve the problem. So you say, I need this quantity to calculate the answer, but I'm not given that quantity. I'm given these other two quantities that I can calculate that quantity with. Okay? Um, so putting together the formula that you're going to use or doing the calculations that you need to do um, to get the information that you need. Then step 3, you carry out your plan. That's where you actually do the calculations. Um, and then once you've done the calculations, you need to go back and say, okay, now that I have this number, does it actually work for the information that's given? Uh, so that's really going to be what we're after today. It's really too bad that um, we're having to work from home because this is really a good lesson for group work. It's really good to bounce ideas off of people. So if you can find someone um, in your home that you're quarantined with and kind of discuss some of the problems with them, see if they can give you some ideas, that would be good. But if you can't, at least think about them. So that's the idea for the class today. Um, we're basically just reading problems, and as we go, they're going to get more complex. The first ones actually kind of walk you through the steps, but then they get more complex as we go along. Um, so, at any rate, if you want to go on to um, the practice problem for our classwork, question 1. they're kind of stepping you through the steps. So question one, what information is provided in this statement that you're likely to need? Write it all down. So read the problem and make a note of the information that you're given. All right, so if we look at the problem, Jack and Diane are going to start saving for retirement. They deposit $1,000 in an account to start out. So that's important. They plan to deposit $50 each month. And you see, we're already starting to talk about a start and what happens every time. How long will it take until they've deposited 4,500? Yeah. And that actually is the answer to question 2. I should have had you do question 2. We're actually asking how many months, and I'm going to write it that way instead of how long, because that's more clear. How many months to get 4,500? Question 3, it's asking you to start devising a plan. So answer question 3 and then come back to the video and we will discuss it. Okay, so first let's devise a plan. Let's plan to do this using arithmetic. How much would you add each month? How much needs to be added? Total to get 4,500. So we start with 1,000. How much do we need to add to get 4,500? So we have 1,000. We only need to get 3,500. That's how much we need to add. Okay. So then execute the plan. Perform an arithmetic operation based on your answers to question 3 to solve the problem. Arithmetic operation just means you do some calculations. So come back to the video once you've answered the question, answered or solved the problem. Okay. All right. Now that you've got an answer for question 4, we get $50 every month. And I need 3,500. I need to see how many 50s are in 3,500. I'm going to use division to tell me that. So there are 10 50s in 500. There are 20 50s in 1,000. I've got 3,000, so I've got 3 20s and a 10, which gives me 70 months. I'm going to go ahead and put my units in. I thought I wouldn't, but I got $50 per month, and my dollars cancel. So I don't have dollars in my answer, but I do have months. And since the months was in the denominator of the denominator, it ends up just being the units in my answer. Step 5 is check your answer. So perform a calculation to check. So do that really quickly and then come back to the video. All right. So to check this, we have to say, okay, we're going to start with $1,000. And we're going to add $50 70 times. And if you go to your calculator, 50 times 70, 5 times 7 is 35. I have two tens in there that I have to multiply also. So I get 3,500. 3,500 plus 1,000 is 4,500. If you want, you could do that on your calculator. Nothing wrong with that. So we did have the correct answer. It will take 70 months to find to save 4,500. Okay. We want you to redo that problem now using algebra. So you'll notice they're giving you some variables to work with. So start over, devise a plan, but now use M to kind of represent what you're wanting to accomplish. So restart the video once you've done that. Okay, so same story. They deposit $1,000, $50 a month. We're using M to represent the number of months. A lot of times, when we can, we use the first letter of the word. So M represents months. So describe what that quantity is. M equals months. Okay. Question 7, we're actually starting to write expressions using the variable. So come back to the video once you've answered question 7. Okay, question 7. If $50 is being deposited each month, how much will be deposited after M months? Hopefully we got that figured out from the work we've done before. Remember, when we did the arithmetic, we multiplied 50 times 70 because we deposited $50 70 times. Now we're going to deposit $50 M times. When I write 50M, that means I'm going to multiply 50 times the number of months. Okay. Use this to write an equation that describes the problem. So 50M, to calculate the amount in the account, I'll take 50 times M, and I'll add the 1,000 that I started with. But they asked us to write an equation that describes the problem. So in the problem, we want to see how many months it takes to get 4,500. So I want that to be equal to 4,500. And you'll notice we now have an equation that we can solve. And if we solve an equation, we first subtract $1,000 from each side, which is what we did when we did the arithmetic. The first thing we did was subtract $1,000. just that now we are subtracting it from both sides of an equation. We get 50m equals 3,500. To solve that, we divide both sides by 50. Um, and if you think back to the arithmetic, we were thinking our way through. Once we knew we needed to add 3,500, we divided by 50 to get 70. So now we can say m equals 70 months. So question 8. Kind of thinking more about the process rather than actually doing some calculations. When you develop a strategy to solve a specific problem, then adapt that strategy to a variety of related problems. That's called generalizing your approach. In this case, the essence of the problem is that we had a starting value of some quantity, in this case $1,000, and we're adding $50 to it regularly. So generalize this problem to develop a framework that would allow someone to input any starting amount and any monthly amount and be able to quickly determine how long it would take to reach a specific savings goal. Look very carefully at the equation you wrote in question 7 and identify exactly what every number or letter in your equation represents. Okay? This is a more challenging problem. Um, so you had the $50 to start with. You had the $1,000. I'm sorry, the $1,000 to start with. The $50 every month. To generalize it, you need to write variables for those quantities as well, and you need to identify them. Just like I said, m equals months. You need to say what each variable means. Um, then you need to write that equation using those variables, and you need again to solve for the number of months. So try that really quickly. And okay, now that you've looked at question 8, I'm going to identify the quantities. So my $1,000, I'm going to call that S. And I'm going to say S equals the initial deposit. Doesn't matter whether you used S or not, that's completely unimportant. As long as you say it refers to the initial deposit, okay? Or the starting balance, whatever you want to call it. As long as you identify it, you're fine. And I need a variable for the $50. I would call it M for monthly deposit, but we're using M for the number of months. I'm going to call it R because I see regular intervals up here. So R equals the monthly deposit. Okay. And it stated earlier, but I'm going to write it again anyway. You didn't need to. M equals the number of months. And this is actually we're setting up to do, um, to solve a literal equation, like we did in the other units. So if we want, um, actually, I'm also going to include A for account balance. Okay, sorry about that. The recording program cut me off, so I had to splice the video together. Anyway, we are going to call A the account balance. So, just like I did before, instead of doing the 50 times M, I'm going to say RM. So 50 is the monthly deposit, R is the monthly deposit, M is the number of months. I'm going to say R times M, and when we write them next to each other, that means times. Um, just like I added the $1,000 before, I'm going to add the initial deposit. So R times M plus S. And that's going to give me the account balance. Okay. So I've identified exactly what each letter represents, and I've written the equation in general terms. So the last thing I want to do, we want to be able to quickly determine how long it would take. So we want to be able to just plug in numbers and get the number of months. So I'm going to solve this equation just like I solved the equation in the last problem. RM equals A minus S. And if we think back to the way we did this when we just thought about it algebraically, we took the account balance we wanted, $4,500, and subtracted the initial deposit, $1,000, to get $3,500. We needed to make $3,500. And then we divided that $3,500 by the monthly deposit, or the regular deposit. I always run out of room. Um, so we have R divided by R. That just leaves us M. So M equals A minus S divided by R. That's what we mean when we say generalize. Looks like we've got a did you get it coming up. So look at that did you get it. Check your answer in the back of the lesson. If you don't get it and you don't know why, um, send me an email or um, uh, try to get a hold of me somehow. Okay? Um, and before we move on, a useful reminder: the two most important elements of understanding the problem are the two things you should always do when attacking a word problem. Write down any relevant information. Write down exactly what you're trying to find. Let's go on to our group work. So, group work, um, we've got a problem here. So go ahead and work through the problem solving steps. Um, Go ahead and do all of question one. Uh, so question one is has the 4 different steps. So write down the key information. What exactly are you asked to find? Step 2, devise a plan. They suggest you draw a diagram. Then they ask you some questions that kind of help you think through carrying out the plan. And then finally, they want you to check. So do all of question 1, A through F, and then come back to the video. Okay? All right, that was a lot of work, I'm sure. So write down the relevant information. Suppose that you have 4 people in your family and you want to hang a picture of each family member. The wall you choose is 60 inches wide, and each of the picture frames is 8 inches wide. To make everything look right, you want to make the wall space between the edges of each frame identical, and put that same amount of space on the ends of the wall. So between the wall and the first picture, and between each picture, between the last picture and the other wall, you want the same space. Okay? Each frame has a single hook in the center of its back. Where should you put the 4 nails needed to hang the pictures? Okay? So really quite a challenging problem, more challenging than it looks, but we'll see that as we go through. So write down the relevant information. There's 4 pictures. Um, the wall is 60 inches wide, and each picture is 8 inches. Okay. What exactly are you being asked to find? Well, we're kind of talking about it like what's the space in between each picture. Um, but really, that's not what we're being asked to find. We're being asked to find where do you put the nails. As we go through the problem solving process, we will find that the space between each picture is important, but it won't be our final answer. So, part C. Now we have to devise a plan, and I am going to draw a diagram as they suggest. Not to scale, but it helps to draw it as much to scale as possible. And I've got my 4 picture frames, and I've tried to evenly space them. Also going to put my walls on the other end. Um, I'm going to make a note that each of these is 8 inches. Double check. 8 inches wide. And my total length is 60 inches. Based on the description of the problem, including the relevant information you wrote down. So I've got my 8 inches, I got my 60 inches, and I've got the 4 pictures. So based on the diagram, you should be able to note how much space will be covered by the frames and how many blank spaces there will be. Okay. So space covered by the frames, I've got 4 frames that are 8 inches wide. So I've got 4 times 8 inches is going to be covered by picture frames. If I want the total space in between the frames, 4 times 8, 2 times 8 is 16, 2 times 16 is 32, 60 minus 32 is 28. So there's a total of 28 inches in between the pictures and the walls. Um, Once you know that, you can find the total blank space and divide by the number of spaces to find how far from the edges of the wall the edge of each frame will be. Um, so one of the big problems, people don't draw a picture. Um, they divide 28 by 4. And it's set up so it looks like that's an easy way to do this. You just get 7. But we'll notice actually there are 1, 2, 3, 4, 5 spaces. That's actually part of the problem solving process. Um, to get away from um, just plugging numbers into things, we need to really think about the situation. So we need to take our 28 divided by 5. And that's going to give me 5 and 3/5, or 5.6 inches. So we need 5.6 inches between each space and between each picture and between each picture and the wall, each wall and the adjacent picture. Okay. Okay. So, and that's actually how much of the 60 inches will be covered by picture frames. Um, how many empty spaces will there be? What is it we're trying to find? Give that quantity a variable name. Okay, so we're actually trying to find the we need the location of each nail. So I'm going to say n equals the distance from the left wall to the first nail. Hopefully you can remember what I said, because you can't read what I wrote there. Note that the total 60 inches of the wall can be described by space covered by frames plus space in between frames. Use this idea to write and solve an equation that finds the space between the frames. Then use that to describe the location of all 4 nails. So we found the space in between each frame was 5.6. So at this point, I'm going to redraw my picture, putting in the information. So 5.6, 8, 5.6, 8, 5, 5.6, 8, 5.6, 8, and 5.6. So now, for the distance to the first nail. Nails are going to be at the center of the picture frames. So picture frame is 8 inches wide. So my first nail is going to be right here. My second nail is going to be right here. Third nail and fourth nail. So the first nail is going to be at 5.6 plus 4 inches equals 9.6 inches. Okay. Second nail I'm going to take my 9.6 inches and I'm going to add the 4 inches to get to the right side of the. Okay, had to splice again. So second nail, I'm going to be at my 9.6 inches to get to my first nail. Let's not do it that way. Let's say I've got 5.6 to get to the first picture, 8 inches, and then 5.6, and then another 4. So I've got 2 times 5.6 plus 8 plus 4. So 10, 11.2, 19.2, 23.2. And if I look at that, I actually added 13.6 to my 9.6. And that 13.6 actually is this part of the. So I have 4. Four and 4 and 5.6. So that gives me the 13.6. So for my third nail, I can take my 23.2 plus 13.6 equals 36.8. My fourth nail, I take my 36.8 plus 13.6, and I get 4950.4. Okay, inches. And if I look at my end, so I'm saying my last nail is at 50.4 inches. So if I add another 4 inches for the last half of the picture, I get 54.4. And then if I add my 5.6, I would get 54.4 plus 5.6. That actually gives me 60 inches, which is the width of the wall. So that is actually the final thing. Use your diagram to check if the spots will work according to the statement of the problem. So I know then that they will, because the nails are evenly spaced, and I end up with the same spacing between the walls and the pictures as I do between each picture. So, go on. think about generalizing your approach. Same thing that we did with the Jack and Diane problem. We need to have variables for each thing, and they're telling us X is the space between the pictures. Choose a variable name for all quantities in this problem. Write a general equation as described above. Go ahead and do that and then restart the video. Okay. So question 2, I need variables, so X is the space in between the pictures. So number of pictures, P equals number of pictures. W equals width of each picture. It's fine if you use different variables, there's no problem there. And T equals total width. Okay, so use the numbers from the problem to verify that your formula provides the same answer. Actually, we need to write a formula. So we'll come back up here. I'll write the formula up here. So PW plus the quantity P plus 1 times X equals T. Okay. And write the general equation as described above. So now we want to check and see that that works. So P is the number of pictures. So actually I'm going to rewrite the equation. PW plus P plus 1 X equals T. So 4 times the width of the picture is 8 plus X was the space between the pictures. 5 times 5.6. And if we put that in the calculator, let's do that real quick. So 4 times 8 plus 5 times 5.6. 8 plus 5 times 0.6. That does in fact equal 60. So that checks. Question 4. Your family now has 5 members since you decided to adopt a puppy. Now you have 5 pictures evenly spaced on the wall. Use your answer to question 3 to find where to put the nails. Describe why this is better than just starting over from scratch. So now we have our equation, PW plus P plus 1 X equals T. So now P was the number of pictures. We now have 5. W is the width. There's still 8 inches. And we don't know the X, but our wall is still 60 inches. So now we have to find the space between the pictures. 5 times 80 is, 5 times 8 is 40. So I just subtract 40 from both sides. Now I just divide both sides by 6. 18. Confused myself. 6 goes into 20 3 times with 2/3 left over. So 3.67 inches. Why was that a lot easier? Well, we'd already done all of the work. We just plug numbers in. And actually, most people like plugging numbers in. We've written our formula. We just plug numbers in. People enjoy that. Looks like we have a Did You Get It coming up. Go through the problem solving process. See if you can figure out where to dig the holes. Check your answer with the lesson in the back of the lesson, and send me an email if you don't figure it out. Question number 5. Question number 5 is an interesting problem. This is really challenging. I've been surprised, though. I have a lot of students actually get the answer to this problem. So take a look at it. Spend quite a bit of time trying to figure it out. Once you feel like you've got an answer, come back to the video and we'll discuss it a little bit more. Okay. One of the first things people really notice with this problem is that we have distance measured in a lot of different units. And so the first thing that most people do is try to get all of the distance units to be the same. That's kind of challenging because we have miles and we have inches. So you have to ask yourself, do I want to change inches to miles, which gives me a really small decimal? Or do I want to change miles to inches, which gives me a really big number? Or do we want to do something in between? Change everything to feet, change everything to yards. But that will get you moving on this problem. So try that and then come back to the video. Okay, now that you have everything in the same units, another thing I like to do is ask people the question, if you're going 50 miles per hour for 3 hours, how far would you go? And then if you're going 50 miles per hour and you drive 450 miles, how long did it take you? Usually asking those two questions kind of prompts people to figure out a way to solve this problem. So I'll let you do that. And then generalize your answer. Okay. And answer question 7. How can you make your answer more accurate? I'm not actually going to give you the answer to this. If you want to discuss it more, send me an email and we'll try to set up a time to do the WebEx on that. Check the Did You Get It? And then the last problem, crop dusting service Hired to spray a chemical pesticide over a field of broccoli. Okay. So plane has a 350-gallon tank that at the moment contains 80 gallons of 0.5% solution. So 0.5% of the liquid is actually pesticide. The rest is water. The goal is to find how many gallons of pre-mixed 1% solution would need to be added to increase the concentration in the tank to 0.8%. Okay. So how many gallons of pesticide are currently in the tank? So we've got 350 gallons. I'm sorry, you should stop the video and answer these questions yourself, then come back and check your answers. Anyway, 350 gallons times, assuming you have worked this out on your own, times 0.5%. When I go to my calculator, 0.5%, I need to divide by 100, get 0.005. I multiply that by 350, and I get 1.75 gallons. So question B, answer that and come back to the video. If we add X gallons of the 1% solution, how many gallons will be in the tank? So 1% is 0.01. Okay. And I multiply that by X. That tells me the number of gallons. If I add X gallons of the solution, that tells me, oh, I'm sorry. I'm thinking about this wrong. So if we add X gallons, how many gallons total will be in the tank? We're going to have 350 gallons plus X gallons. That's going to give us the total in the tank. So question C. Question C is actually what I was trying to do before. So go ahead and do question C and then come back to the video. So if we're adding X gallons of 1% solution, how many gallons of the pesticide are we adding? That's where we add our 0.01x. Tells us how many gallons of the pesticide we're adding. That's how much. Then they want to know how many gallons of pesticide will we have total. We're actually going to add the 1.75 gallons that we got before. So question D. Go ahead and do question D, and then come back to check your answer. Okay. Now set up an equation that has two different expressions to describe the amount of pesticide in the tank. One expression uses your answer to question 8b, along with the fact that the new solution is 0.8% pesticide. The other expression is your answer to question 8c. Then solve to find the number of gallons that would need to be added to the mixture, added to make the mixture 0.8% pesticide. So if we go back, we know our total is going to be 350 plus X. And so our total volume is going to be 350 plus X. We want the volume of pesticide in the tank. We're going to multiply that by 0.8. That would give us the volume of pesticide in the tank. But we also know the volume on the pesticide in the tank is going to be 0.01x plus 1.75. Okay. So we go about trying to solve this. Um, 0.8 times 350. I'm going to distribute 0.8 times. Okay, this video's got a lot of splices in it because it's taking me a long time to explain everything, I guess, but this is a really complicated lesson, so there's nothing wrong with that. At any rate, two different expressions for the volume of pesticide in the tank. So we can take the entire volume of the tank, multiply it by 0.8, actually 0.08. We'll just go straight to that because it's 0.8%. Um, and that's equal to 0.01x plus 1.75. So that's also the volume of pesticide in the tank. Because the 1.75 was the gallons of pesticide before. Uh, 0.01x is the gallons of pesticide that we're adding. So both of these will give us the uh, volume of pesticide in the tank. Okay? So first thing I'm going to do now is distribute 0.008. And I think I had been doing the 0. So, so I'm just going to say 0.008. I had done 0.8 times 350 before, then I would have had to divide by 100. That would work. So, but this way I divide by the 100 in my head, whatever you want to do. So that gives me 2.8. So when I distribute my 0.8, had a student last semester call that rainbowing, which is nice. I like that, but I still say distribute 2.8, 2.8 plus 0.008x equals 0.010x. I added the 0. Hopefully you'll see why I added the 0 in a moment. Plus 1.75. And so now I've got an equation where I've gotten rid of my parentheses. I'm now going to subtract 0.008x from both sides. And that's why I added the 0 to the 1, 0.010. So now I have 2.8 equals 0.002 x plus 1.75. I can now subtract the 1.75 from both sides. And I get 1.05 equals 0.02 x. To get x now, I divide both sides by 0.02, which is like multiplying by 1,000 and dividing by 2. So I get x equals 1050 divided by 2, 1050 divided by 2, which is 525. Let me check that. So 2.8 minus 1.75, it is in fact 1.005 divided by 0.002 gives me 525. So I know the new volume of the tank has to be 525. But that doesn't answer my question. I have to think about this now. Let's go back and double check, then solve to find the number of gallons that would be needed to make the mixture possible. I'm sorry, that we had set it up so that that was in fact um, the number of gallons that need to be added. That's not the number of gallons in the tank. Um, so we have solved for the number of gallons. Um, how many gallons of the mix, 1% mix, would need to raise the concentration of the tank to 0.9%? Don't start over from scratch. Just adapt your work from part C. So take what you can from part C and figure out what you would do to change it to 0.9%. Okay. Once you do that, come back and we'll check your work. Okay, so if we go back to part C, we had 0.01x. Uh, we've still got the same 1.75 gallons. We've got 350 gallons at 0.5%. We've still got 1.75 gallons in the tank, 1.75 gallons of pesticide. Um, so we can write that expression instead of 0.01, I can now say 0.009 because I've changed this from a percent, 0.9%. I've divided by 100. Multiply that times the number of gallons added. We will add 1.75 gallons. That's going to give us the total gallons of pesticide in the tank. Well, we can oops, 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 oops. I'm sorry, I'm getting myself confused here. We still have 0.01%. I'm sorry, we still have 1%, which is 0.01x. So we're still adding the same concentration. We still have the same gallons. And we're still going to have 350 gallons plus X gallons as the final volume in our tank. We're going to multiply that times 0.009. Okay, so we're really using the same information. We're just now saying 0.09. So we don't have to start over from scratch. And as before, I'm going to distribute okay. 0.009 times 350 gives me 3.15 plus 0.009 0.009x 0.01x plus 1.75. And I can do the same thing. It's 0.009x minus 0.009. It makes it helpful to put 0.010 for my expression on the right hand side. Now I get 0.001x plus 1.75. Now I subtract 1.75 from both sides. I get 0.001x. My 1.75s cancel out. And 1.40, I believe. And I divide both sides by 0.01. These cancel out, I just have x. When I divide this by 0.001, you can do it on a calculator to check, but that's really like multiplying by 1,000. So I need to add 1,400 gallons of the 1% mix to get a concentration of 0.9%. Okay, and that brings us to the end of the lesson. Don't forget we don't do the technology, but you do want to do the applications, and you want to look at the you want to do the online homework, which is the ALEKS. Okay? So go ahead and do that, and let me know if you have questions. Thank you.